All right, let's talk about a piece of technology you've definitely used, probably even today, whether you know it or not. We're diving into message queues. They are the absolute unsung heroes of modern software, the secret ingredient that keeps our digital world from falling apart. So let's find out how they do it. You ever been on a website during a huge Black Friday sale? You've got the perfect thing in your cart, you hit checkout, and nothing. The whole site just grinds to a halt. The app was working perfectly a minute ago, so what on earth just happened? Well, that experience right there gets to the very heart of the problem that message queues are designed to solve. You see, in a lot of systems, every little piece is directly connected to another. So when one part gets slow or just completely breaks, maybe it's the payment processor getting slammed with requests, it creates this awful domino effect. One failure triggers another, and before you know it, that cascade brings the entire application crashing down. So let's take a closer look at exactly what's happening when these systems get overloaded. You're about to see why the most direct way for things to communicate is often the most fragile. Okay, so imagine one service has to talk directly to another one. It asks for something, and then it just has to wait for a response. Now, if that second service is slow, the first one is just stuck, completely frozen. And what about all the other services that were waiting on that first one? Yep, they get stuck too. This is a classic bottleneck, and it shows you just how fragile these tightly coupled systems can be. But what if there was a better way? A way for all these services to communicate without having to wait for each other? Well, this brings us to the hero of our story, the asynchronous solution. And that solution, of course, is the message queue. Now, there are two really important words to focus on here: intermediary and asynchronously. A message queue is basically a middleman. It's like a postbox. It holds onto messages, which lets the sender drop off the letter and just walk away without having to wait for the receiver to come and pick it up. The best way to think about this is a busy restaurant kitchen. A waiter takes your order, they clip that little ticket onto the order rail, and then what do? They immediately go to serve another table. They don't stand there tapping their foot waiting for the chef to cook your meal. The waiter and the chef work independently at their own pace. That order rail, that is our message queue. So how does this actually work under the hood? Let's follow a single message on its journey to really understand all the moving parts. First up, we've got the producer. In our restaurant, this is the waiter. The producer's job is super simple. Create a message, that's our order ticket, and just put it onto the queue. That's it. It doesn't need to know who's going to process it or when. And on the other side, we have the consumer. This is our chef. The consumer's job is to just keep an eye on the queue. Whenever it's free, it grabs the next message in line and gets to work. See, the chef doesn't care which waiter dropped off the ticket, only that there's an order that needs to be made. And then, of course, you have the message itself, the actual order ticket. Every message has two parts. It has the payload, which is the core data, like 1 cheeseburger, no pickles. And it has metadata, which is basically data about the data, like the table number and the exact time the order was placed. So, this all comes together in a 6-step life cycle. 1, the producer creates the message. 2, it's enqueued, fancy word for added to the queue. 3, it's stored safely. 4, a consumer dequeues it, pulling it off to start working. 5, and this is absolutely critical, the consumer sends an acknowledgment back saying, hey, I'm done and I did it right. And only then, after that confirmation, is the message deleted. This is how we guarantee that no work ever gets lost. This really simple process, just having a place where messages can hang out and wait, unlocks some incredible advantages for building software. You could honestly call them superpowers. I mean, the list of benefits is pretty amazing. We get decoupling, so all our services can work independently. We get huge boosts to speed and reliability, but most importantly, we get a system that's just built for resilience and growth, with things like fault tolerance and scalability baked right in from the start. Let's look at a couple of these a little closer. So let's start with fault tolerance. What happens if our chef, the consumer, suddenly gets sick and has to go home in the middle of a shift? Do all the orders just get thrown away? No way. They just wait safely on the rail until another chef can come in and pick them up. For your favorite app, this means that a temporary glitch in one tiny part of the system doesn't cause a giant error page for you. The whole system is just more resilient. And what about scalability? Let's go back to the restaurant. If that order rail gets totally flooded with tickets on a Friday night, what does the manager do? They don't hire more waiters to take orders even faster. No, they add more chefs to the line to cook faster. It's exactly the same with a message queue. You can handle these huge traffic spikes by simply adding more consumers to process all that work in parallel. Now, not all queues work the same way. There are two main models. The point-to-point model is when a message goes from one producer to just one single consumer. It's a specific task for a specific worker. But in the publish/subscribe model, one message is broadcast to many different consumers all at once. The easiest way to think about this is like the difference between sending a direct message to a friend versus posting in a group chat where everyone sees it. So I know this might all sound a little abstract, but I promise you, you interact with systems built on message queues every single day. Let's look at a few real-world examples. Message queues are pretty much the backbone of modern microservice architectures, letting all those tiny, independent services talk to each other reliably. They're also perfect for background jobs. You know when you sign up for a service and get that confirmation email instantly? That was probably sent using a message queue. They handle those massive traffic spikes during flash sales, and they're essential for any system where losing a single message is just not an option. And there are so many powerful tools out there that you can use to implement this stuff. RabbitMQ is a super reliable workhorse that's great for lots of jobs. Apache Kafka is the undisputed king of handling massive real-time data streams. And of course, all the major cloud providers like Amazon and Google have their own managed services that make it incredibly easy to get started. So as we wrap up here, it's pretty clear that using a message queue isn't just a small technical choice. It actually fundamentally changes how we think about communication inside our software.
And this quote right here, it just nails it. The power of decoupling, letting different parts of a system operate and evolve independently, that is the secret to building systems that are not just functional today, but are also flexible and scalable enough to handle whatever tomorrow brings.
So here's the most crucial point of all. A message queue isn't just another tool you drop into a project. It's a fundamental architectural strategy. It's a conscious decision to build for resilience, to design for scale, and to prepare your application for success. And that leaves us with one final question, one that brings us all the way back to that crashing website we started with. When you look at the systems being built all around us, you have to ask, are they just built to work, or are they built to handle success? Thanks for joining me.